My name is Anneli Mossberg, and I will be presenting the new features in the integration between Mathematica and Wolfram SystemModeler 4, including improved streamlined workflow, real-time simulation, and programmatic model creation. Let's start with improved streamlined workflow, which has greatly deepened the integration between SystemModeler and Mathematica. In the previous version of the SystemModeler Link, the intended experiment settings, such as stop time and step size, had to be guessed at or looked up in model documentation. Although it's still useful, it could lead to problems, as we can see in this plot, where the most interesting behavior occurs during the first couple of seconds, but it becomes nearly indetectable when using a stop time of 10 seconds. The SystemModeler Link now automatically uses the experiment settings set by the model creator, thereby eliminating any unnecessary guesswork. Here it picks up the stop time from the experiment settings, and we can easily see the behavior the model creator intended us to see. Mathematica and Simulation Center are now more deeply integrated than before. Simulation Center can, for example, be opened from within Mathematica using function WSM Simulation Center. Adding a model name as an argument both starts Simulation Center and opens an experiment with the model. Also, the simulation results can be seamlessly transferred from Simulation Center to Mathematica using the Copy Result as Mathematica Object button in the Experiment Browser toolbar. The copied object can be pasted into Mathematica and be used as a regular WSM simulation data object, for example, to plot or to further analyze the simulation results. If you don't want to copy the entire simulation results, you can also choose to only copy the results for certain variables by right-clicking the variable and choosing Copy as Mathematica Object in Simulation Center. Function WSM Simulate now has support for using Mathematica's powerful differential equation solver, NDSolve, which adds another strong solver to choose from when simulating your models. This functionality has a few nice advantages. For example, NDSolve can solve some more complicated systems that the built-in solvers in SystemModeler might otherwise have trouble with, and it also increases the performance in some scenarios. For example, solving this bouncing ball system is approximately 3 times faster using NDSolve compared to the automatically chosen solver. When using WSM Plot to plot more than one curve, plot legends are now automatically created. The automatic legend is the name of the plotted variable, in this case x1 to x5, but it is also possible to choose the variable description as the plot legend instead. Model diagrams are graphic representations of models, and in SystemModeler 4 we have added support for retrieving them into SystemModeler. In Mathematica, model diagrams are now used to represent models. Right-clicking a diagram opens up a menu with several model-related options, such as Simulate Model, which launches WSM Simulate. You can of course also copy and paste the model and use it as an input anywhere you usually use a string of the model name. Dynamic diagrams are graphic properties that make it possible to build dynamic graphics into any model. This can be very useful to illustrate system behavior, such as the water level in tanks, as in this case, or the temperature changes in a thermometer. Now we have so far covered streamlined workflow, simulation center integration, and model diagrams, which now takes us to programmatic model creation, an exciting feature that is completely new to SystemModeler 4. WSM Create Model is a new function for the SystemModeler Link. It allows you to create Mathematica models from systems models in Mathematica, either in the form of a transfer function model or a state space model. Models created in this manner are instantly and automatically available in both Model Center and Simulation Center for integration into a larger model or a simulation. WSM Create Model is not limited to systems models though. Mathematica models can also be created from Mathematica by explicitly stating the system equations and the time variable. many Mathematica functions are automatically translated into the Modelic equivalent, and things like discrete events are appropriately converted. The new model can be treated just as any Modelica model created in Model Center and can, for example, be used together with WSM Simulate or WSM Plot. To make your modeling process more efficient, model creation in Mathematica can also be done by connecting already existing SystemModeler components. Simply construct a list of instance names and which Modelica class they belong to. In this case, for example, A is an instance of component abs in the Modelica standard library. You also need to specify a list of connections. Here we wish to connect sign.y to a.u. Finally, function WSM connect components creates the model. We have now reached the last part of the presentation, namely real-time simulation, which is not new to SystemModeler as a whole, but is a completely new functionality for the SystemModeler Link. With the link in SystemModeler 4, it is possible to start a real-time simulation as well as visualize it, all in real time from within Mathematica. The link between SystemModeler and Mathematica also makes it possible to interactively and programmatically provide model input, for example using hardware devices, gauges, and sliders. Model output can also be captured for processing, feedback, and visualization, for instance with plots, gauges, and other animations. The features mentioned in this presentation are only a sample of all the useful features available through the integration between SystemModeler and Mathematica. The newly released Mathematica 10 contains a number of new beneficial features, such as enhanced control systems, hybrid and differential equations, and new visualization methods, as we will see in the next presentation.